let's go over a few equations that you'll be looking at this week. You'll also be incorporating the rules that you know of identities into a few of these. With trig equations, it's really important that you look at them as you would algebra equations. Like for this b right here. So how do I solve equations that have a squared term? Or here, for this first one, if you were to replace sine theta with x, how would you solve that in algebra? So for some of these, we can do simple algebra tricks. Subtract the 6 from both sides to get -1, and then divide both sides by 2. The key thing to pay attention to when you're solving these is how they've outlined theta. Are they asking you to solve theta between 0 and 360 degrees or between 0 and 2 pi? Because if it's between 0 and 2 pi, so if they want theta in radians, then you need your answers to be in radians. So in this case, I want to know when is the sine of theta equal to -1/2. So we can use our reference angles because we know that the sine of theta equals 1/2 at pi over 6. And that sine is negative in quadrants 3 and 4, and so then that brings up the theta values of 7 pi over 6 and 11 pi over 6. For the second one I have here, when we look at this, the idea is to get the theta by itself. So you divide both sides by 12, and 9 over 12 reduces to 3/4. In order to get cosine theta by itself, we have to take the square root of both sides. Well, when we do that, it's a plus or minus. And so when I take the square root of the right side, I get plus or minus radical 3 over 2. Since my answer is plus or minus, then that means that I need a theta from every quadrant. So you start by asking, when is the cosine of theta equal to the square root of 3 over 2? Well, that happens at 30 degrees or pi over 6. And then you want to go to where your reference angle is pi over 6 in quadrant 2. That's 5 pi over 6. If my reference angle is pi over 6 in quadrant 3, then theta is 7 pi over 6. And if my reference angle is pi over 6 in quadrant 4, then theta is 11 pi over 6. So that's where these 4 come from. If you have a multiple theta, like I do in C, where I have the sine of 4 theta equals 1, then we have to be able to identify what 4 theta should equal. So start by asking yourself, when is the sine of theta equal to 1? The sine of theta equals 1 at pi over 2. So I need 4 theta to equal pi over 2. But we're going to take it different revolutions around the circle. So that's what this stands for, is how many k's, how many revolutions will I go around the circle and get answers. So in order for theta to be by itself, you have to divide everything by 4. So when you do, you get pi over 8 plus k pi over 2. And we start at -1, and if k is equal to -1, what is theta? Well, if k is -1, then you'd have pi over 8 minus pi over 2, which is a negative number. So that would be invalid, because remember, theta in these cases is going between 0 and 2 pi. So then we go to k equals 0. When k is 0, theta is pi over 8. So that's one solution. And then notice I plug in k equals 1. So here I've done common denominator. So pi over 2 is the same thing as 4 pi over 8. So if k is 1, then I'm adding 4 pi plus 1 pi and getting 5 pi over 8. And then you check it for k equals 2. Well, that would be 8 pi plus pi, so 9 pi over 8. And if k is 3, that's 12 pi plus pi, which is 13 pi over 8. If k equals 4, if k is 4, then it's 16 pi plus pi all over 8, which is 17 pi over 8. Well, that's larger than 2 pi. So now I'm outside the circle, so I stop. So these 4 would be my answer. You shouldn't have very many of those, but that's how you want to start those. Here's another example. Again, if I just want to get theta by itself, we can subtract 4 from both sides and then divide by 2 radical 2. So cosine theta equals 1 over the square root of 2. If I rationalize the denominator, that's radical 2 over 2. And we know that that happens at pi over 4. Because this is positive, cosine theta is also positive in quadrant 4. So with a reference angle of pi over 4, my second angle is 7 pi over 4. Here's another one where your theta is a multiple. So again, notice that you're asking yourself, ignore this in parentheses and just say, when is the sine of theta equal to -1? Well, that happens at 3 pi over 2. So I need the parenthesis 2 theta minus pi over 2 to equal 3 pi over 2. And then we add the period and how many k's will I have until I go outside the bounds. So again, I start at -1 and we get theta equals 0. If I let k equal 0, then theta is pi. If you follow my steps, I guess I skipped. Remember again, I want to get theta by itself. So I added the pi over 2 to the right side. So 3 pi over 2 plus pi over 2 is 2 pi. And then divided everything by 2. So then once I get this last equation is when I plug in my k's. And the only ones that work were the -1 and the 0. And my answers would just be that theta is 0 and pi. Let's see. If we do equations, I'm running out of tapeable time. If we do ones where our answers are in radians and we have to use our calculator, just remember that when you do this, you can still use your inverse sine button, and you would type in inverse sine of -0.88, and the answer that you get when you plug that in is going to be your reference angle. So you take that reference angle of 1.08. Notice that the value is negative, so that means I'm in quadrants 3 and 4. If my reference angle is 1.08 or 1.076, then in quadrant 3 we would add that to pi to drop us into quadrant 3, and in quadrant 4 I would subtract that from an entire revolution to get my 2 answers. So that's how you'll do it with the calculators.